Hi everyone, I'm Yukoda, sales engineer at Precisely. We help companies achieve data integrity, making sure data is accurate, enriched, and contextualized for better decisions. Today, we explore how to use advanced spatial analytics and contextualized data to define effective geographies and place ads where your audience are. Now, let's switch roles. I am a data analyst for a grocery chain with 20 stores in California. My goal today is to use geospatial analysis and contextual data to find the best spots for advertising, targeting competitor customers. First things first, I have an Excel file with store addresses. Using precisely these geocoding services, I will map all these 20 stores. Here is the results. Through Precisely API services, I have access to millions of points of interest across the entire United States and other countries. I'm going to make an assumption for advertising purpose. Place more than 2 kilometers away from my store, having minimal to no impact. So I will draw a 2 kilometer boundary around this location and download the points of interest inside that boundary. These points come with several attributes, names, sales volume, address SIC classifications, plus a 4-level category classifications. Overall, sometimes some business categories represent food traffic generators, some represent competitors, and some are not relevant. There are thousands of groups, but to narrow down the categories that matter most, I'm going to use machine learning. To keep this video short, I have repeated the process offline to download place data for all 20 stores. Let's jump into Python. From here on, we will work in code. First, I will join the stores and places tables using 2 kilometers distance as the join condition. Next, I summarize the data. For each store, I want counts by category. I'm using 3 category levels and create a key field that combines them. This will help later when we pivot the data. Now I will remove low representative categories. For example, if only 2 of 20 stores have hospitals nearby, that's a too small sample. So I will drop categories present in fewer than half the stores. I need one row per store with categories as columns. Column names can't be too long due to MapLink limitations. So I will create short names. And then I pivot the table. After standardizing the data, I run PCA and ask for the top 5 components. The first component explains 47% of the variance. The second does a bit more, and so on. So really, the first component is enough to guide us. I also get a correlation matrix. Values closer to 1 or -1 means a strong relevance. Look at this. Here is the group with our direct competitors. Here is another interesting group, potential indirect competition. Since you're looking for advertising spots, some categories could be footfall hubs like recreation services, clinics. But for today, let's pick something unusual, laundry and cleaning. The hypothesis, Maybe customers stop by our store after doing laundry. I filter business in this group, then verifying using SIC codes to keep only coin-operated laundries. Here it is. Next, I'm going to take a look into our competition, selecting other grocery stores. I see one of my main competitors here. I'm going to filter and put their locations on the map. Here are some points that are closer to my competitors, and I can add other layers of information. We can make this demo even more compelling by integrating precisely place IQ data, enabling us to highlight locations with the highest foot traffic. In this example, icon size is used to visually represent recreation clubs with the largest number of visitors. This concludes the first part of our demo. We have leveraged advanced map info capabilities to identify key categories of points of interest, traffic generators with the greatest potential impact on our grocery store chain. PCA also helps identify areas similar to where we already succeeded. I divided a new stud area into polygons. I can overlay with demographic data, um, street data, points of interest, and using the PCA coefficients, I can create a heat map where red means higher similarity. The time is short, so we can't dive into other Python data science tools. But if you are curious, you can check the scikit-learn. That's all for today. Thanks for joining and see you next time.